All right, we're going to go through this next example. We are given two similar rectangles, and we're asked what is the length scale. The first one says, what is the length scale between these two rectangles? Let's start with that. So let's just compare the length scales. I'll just compare the length with the length. So this is a 5 to 10. So that was the lengths. Let's also, we don't have to do this, but I just really want to confirm it. Let's compare the widths. The width it's a 2 to this width is 4. And we see that I can reduce these down. If I divide this by 5 and this by 5, this becomes a 1 to 2. And if I divide both these by 2, this also becomes a 1 to 2. So this confirms for me that the length scale between these two, it's a 1 to 2 ratio for the length scale. So that is question A. So for every 1 centimeter over on this side, I have 2 centimeters over on this rectangle. So we're done that question. We've figured out the length scale. The next question says, what is the area scale between these rectangles? So let's compare the areas. So we'll say, so this is question B. We'll say rectangle A area is going to be 5 times 2, which equals 10 centimeters squared. Let's just right away, we'll compare that with rectangle B. So in rectangle B, the area is 10 times 4, which is 40 centimeters squared. So now when I compare the area, I say to myself, okay, area scale. And area scale, well, it's 10 centimeters squared in the first diagram, results with 40 centimeters squared in the second diagram. And now I can reduce this, divide both these by 10. Area scale, so AS, area scale is 1 to 4. What this means is every 1 little centimeter squared in this first rectangle will give me 4 centimeters squared in the second rectangle. That's all good. Let's just show, though, this takes a little bit of time doing this way. So let's just show method 2 to find area scale. Uh-oh. I think my power just went out. All right, that's okay. Hold on 1 second. We're still going to finish this video because you know what the question is and we're almost done. All right, you guys, typical. Technical difficulties every time. I can't get away from it. But we'll still finish this question. Method 2 to find the area scale. At the start of the lesson, we were told area scale is equal to length scale squared. And a way to remember that, the way that kind of makes sense, is because area is squared, right? Area, we had 40 centimeters squared, 10 centimeters squared. So to find area scale, we'll also square that. My length scale, at the start, it was a 1 to 2 ratio for my length scale. So when I square this, well, 1 times 1 will still give me 1, and 2 times 2 will give me 4. So we'll get the same answer for area scale. This still communicates that 1 centimeter squared in that smaller triangle will result in 4 centimeters squared in the larger triangle. So either way, using this method or using this method where we actually compare the areas, I still get the area scale is 1 to 4. All right, thanks for dealing with those technical difficulties, power outages, but it doesn't matter because we are so smart that you guys will figure it out anyways. Good job.